But 6.7, solving radical equations. All right. So radicals and radical functions. We've seen this slide already. For this assignment, from what I remember, we're just looking for pretty much the principal squares. Now, we shouldn't have any of this stuff right now, but you shouldn't, if you do see any square roots where the radicand is a negative, the inside of the square root is negative, right now we get to say it's not real. But after tomorrow in 6.9, we're going to do those. We're going to do them because they're so much fun. But if the negative's on the outside, it's just telling you that whatever the answer is, make it negative. All right, that's nice. And like we've seen, we don't want any square roots in denominators. I don't remember if we see them on this one, but probably not. Really what we're looking at is kind of like we would with regular problem solving, is it's kind of its own principle of equality with exponents. So if you have square roots, you can just kind of square both sides and then be done with the square root. But now that we've done this with binomials, we're going to have to deal with some of that on this assignment as well. That's not meant to intimidate. It's bringing back something that we've already learned. So, but what we would like here is just to isolate the radical term. If there's two radical terms, meaning they're being added or subtracted, then usually that means we gotta put them on different sides of the equal sign. We'll see. Then it says raise both sides of the equation of the power of the index. I think we're only dealing with square roots, looks like on this one, maybe some cube roots. Excuse me. And then you have an equation because the root should be gone. You solve it from there. If you still have one, then work towards getting that. But that kind of re-initiates this whole process. But you do have to check your answer because sometimes these answers they may not work if you find that they're outside of the domain. Okay, remember, because I think we forgot because of fall break, but if you have a square root like this of x, then the inside, right, the domain, this is just for the domain. We're not doing domain stuff, but just remember, it has to be in the domain to be an actual part of the answer. X, at the very least, it has to be greater than or equal to 0.
Right, cannot be negative.
Okay, and that would be true as well if you had like 1 plus x. Then 1 plus x has to be greater than or equal to 0. And you solve that for x, you got the domain, which we're not doing today. Again, if you see anything outside the domain, it's not your answer. All right, the principles of power, like I said, it's a principle of equality. So if you have two things that are equal to each other, and this is very basic, it's very abstract. A could be the square root of some garbage plus some other garbage. B could be a fraction with some garbage and more garbage. Okay, but if you take both sides, the whole side, and raise it to the same power, you maintain equality. But again, this is a good way to get rid of roots. Well, the last thing I want to make sure, just like we saw on that last slide, though, make sure you check your answers because it may not be, you may get to the answer and be like, hey, that was good and you did a lot of work and you're feeling good inside, but it's not an actual answer because it doesn't make the equation true. So you just please check, okay? And by the way, your calculator knows how to check for you if you just type it in. That's all I'm going to do to check. I'm not going to write it out and then do it by hand. I'll probably write it out, but not do it by hand. Now, as you know, we start with something fairly basic like this one, and it's fun, and we enjoy it. Well, yeah, but let's go through our process here so that we can make sure that we're on the right track for the other ones which are coming. So on this one, again, what I need here is an x equals. I don't want the square root of x, so how do you get rid of a square root? You raise it to that power of 2. But if you do it to one side, it is a principle of equality. You need to make sure you do it to the other side. So I'm putting the 5 in parentheses. Some students are like, I don't want to put that parentheses there. I don't care. It's going to give you the same answer, but x equals 25 right here. Boom. Okay, now, does x actually equal 25? Well, the equation was saying that we would have had the square root of x equals 5, right? But now we're pretty sure we did that right. X should be 25. Again, does this give us a true statement? Well, the square root of 25 is 5, and 5 does equal 5 last time I checked. So that's true, and now I know I have actually found the solution. Now some of you, I think, would probably just be like, I know the answer to this one. Fair enough. But I'm going to solve this one just to go through the process again, okay? So I don't want the square root. What I really would like here is just a equals something. So I'm going to have to square both sides, right? And again, I'm putting that -5 in parentheses. I do want that in parentheses because it's a negative base. But this would be -5 times the -5 times itself, which is positive 25. All right, that's pretty good. So let's check our answer, though. And again, this may be where some of you guys are like, oh, I already knew the answer. Well, we've just determined that A is 25. And I need to check to make sure this is true. Well, the square root of 25 is actually 5. And we're saying right here that 5 equals -5. That's false. Okay, so A does not equal 25. It can't equal 25. And this goes back to what I was talking about in the beginning. Some of you guys knew what this was right here, because you can't have a square root that equals a negative. Okay, this is like having a square. The area of a square equals a negative value. You can't have that because the area of a square is the side length times side length, and any two values multiplied by each other, even including negatives, -5 times -5, that still give you a positive. So this can't happen. This one, boom, just no solution.
Oh, okay. Could be an introvert.
All right, see, now we're up the ante right here, and it's like, what the crap is going on here? Well, remember, like I said, you got to isolate, in this case, your square root on one side, meaning this, see this -6 or the -6 term? It can't be there. It can't be with this square root of 3m plus 7. I suppose it could, but it would make things really complicated. We'll get into that stuff later. So I'm going to use the principle of equality just to isolate the square root, all right? Meaning I'm going to take that full square root right there, and what I'd like to do is just drop it. And so I got to get rid of that -6 or -6 by, I'm going to add 6 to both sides. We got 10 plus 6, which is 16, all right? Now I have a new equation, and just think about this too, is it's possible that you may just start with some equations that look like this. And if we had started an equation like this, then it would have been just like the last two problems that we've done. But it didn't. It started like this. So here we are, right? And to get rid of that square root, I'm just going to take both sides and square them. Okay, whatever you do to one side, you got to do the other side. Now that power of 2 is going to undo the square root, so I just end up with 3m plus 7 on the left. And this equals 16, is that 256? Thank you. See, and like I said, usually what this will do is it usually will get rid of the square root, which now, it just makes a regular equation for us to solve. Just make sure you check at the end. So I'm going to solve this like I would a regular equation. I'd like to be able to take this 3m and drop it. So I got to get rid of that plus 7, right? So -7 from both sides. I got a 249. And then, since I'm solving for m, let's divide both sides by 3. Oh, it's going to come out, isn't it? 83. Yeah, it's pretty good. So m equals 83. Now, does it equal 83? That's the question. So we got to come back to the original equation up here, all the way back up at the top, and we're going to check for truthfulness. Okay, so I'm going to check for truthfulness. Let's replace the m with the 83. But again, I'm just putting this in the calculator, so let's get this in there. So when I put it in the calculator, I got 10. Oh, that's perfect. I got 10 equals 10, which is true. And so I have the solution. All right, so same thing on this one. I don't want anything on the outside of that radical, the square root, meaning the 4 or the -4. So we gotta work with this one to isolate that square root first. All right, so some principles of equality. We got to do the 4. We got to get rid of this 4 first. You're gonna zero that out. But if I do it to one side, I got to do the other side. Now that will zero that out. Then I can just drop what I have here on the left. Equals -16 minus 4 is -20. And now another principle of equality. We'll divide both sides by -4 to make that a phantom 1. And now I've got the square root of x minus 5 equals 5. So I'm going to continue here in a second, but before I do, some students, when they see this, they say, oh, it equals a negative, so there's no solution on this one. Now, you can't know that, just like we've seen, or hopefully you did see in 990, you can't know until you get rid of the stuff on the outside first if there is going to be an answer or not. So get rid of this stuff first. You can't say right here that there's no solutions unless this stuff wasn't there. Then you could say that. But by getting rid of it, now we see that the square root itself just needs to equal a positive 5, and that's okay. So my principles of equality now, to get rid of the square root, I'm going to take both sides and square both sides. So the power of 2 will undo the square root, so I'm now left with x minus 5 equals 5 to the power of 2. 5 times 5, 25. And this equation, pretty easy to solve. Just add 5 to both sides. So that zeroes that out. Drop the x. X should equal 30, I guess. But let's take a look. Let's make sure that does work by checking. So let's rewrite that. All right, so x should be 30. I put this in as 30, and I put a question mark over my equal sign because I'm just checking for truthfulness. And I only need to work on the left side, but I'm going to put this in the calculator. 4 minus 4 square root, 30 minus 5, enter. I got negative 16. So negative 16 does actually equal negative 16. That's true. So I know that I have, in fact, found the solution. X equals 30. So to solve this one, we need to isolate that square root. Square root of 7x minus 3. Notice it's not like we would with regular equations where we're isolating the variable. We're isolating the square root so that we can square both sides. In fact, I guess you could square both sides right now, but it's going to be better to get rid of that minus 1. So let's do that first. So I'm going to have to add 1 to both sides. Now I can't take x and add 1 and make it 2 x's because they're not like terms. I have to keep them separated, right? So that's going to zero that out. I'm going to drop then my square root of 7x minus 3, which now equals x plus 1. So now that I've got it this far, let's take both sides. Since I've got a square root, I'm going to square both sides. But yeah, now we got a binomial that's being squared. The good news is that the exponent 2 and the square root get rid of each other. So I at least have the 7x minus 3 there on the left. And it's going to equal, but I got to take this x plus 1 and square it, right? So I got to multiply it by itself. Now we do have algorithms to just kind of get this x squared plus 2x plus 1. But just as a quick reminder, let's go through the process there. So you got x squared, x times x, and then x times 1, which would be positive 1x. Then 1 times x, which would be another positive 1x. And then 1 times 1, which is 1. So simplifying this, I got x squared, 1x plus 1x would be positive 2x's, and then the positive 1. So we end up with a trinomial right there, and now we're essentially solving for the trinomial, right? Which means that the 7x and the minus 3, I got to get rid of those. I want this to equal 0, right? So I can just take the roots. So I'm going to subtract 7x from both sides. So 2x's minus 7x's would be negative 5x's. But also, I'm going to add 3 to both sides. Okay, and again, that's to zero out both of these, so I end up with just 0 equals. But 1 plus 3 there would be positive 4. And the x squared, nothing to do with it, it just drops x squared. So now I'm just factoring this trinomial. And if you wanted to, you're welcome to factor by grouping. But I'm going to use the rule. The two factors of 4 that add up to negative 5 would be negative 4 and negative 1. So that would then give me 2 new binomials with x's. And I got negative 4 and negative 1. Now this still equals zeros, right? If I can get both of those factors, x minus 4 and x minus 1, respectively, to equal 0, then I have my two solutions. So x minus 4, if I could get it to equal 0, then it would be true. But also if I get x minus 1 to equal 0, that also would be true. It will make the equation true.
That extra work?
So yeah, just solving these equations like you usually would. So we'd have to add 4 to both sides for this first one, zeroing that out. So x then equals 4. And then same thing with this other one, just add 1 to both sides to zero that out. Now x equals 1. 0 plus 1 is 1. Now these should be our two solutions, right? But I do need to check both. So I'm going to go back to the original equation twice. Now let's just start with x equals 4. So I'm going to take the x's. I'll fix it. And let's replace those with 4s. See what we get.
Yeah, 4 does it.
Yeah, right? Because that'd be 28 minus 3, which is 25. Square root of 25 is 5, minus 1 is 4. And so, yeah, you do end up with 4 equals 4 on this one. That's true. So that clarifies that first part for us. But yeah, let's check. Let's check. So x now we're going to say is 1. And let's check for truthfulness here. So 7 times 1 is 7, minus 3 is 4. Square root of 4 is 2. 2 minus 1 is 1. Yeah, that does check off. 1 does equal 1, which is true. So now we know that both of these are correct. Now in the assignment, you just usually type in 1. Doesn't matter which order, but then you just separate them with a comma. And either way, I mean, it's the same thing. Now let's say that something came out false, like one of them was true, one of them was false. Okay, if it's false, you just may want to go back and check your work on that, but it may also just mean that that answer just is outside of the domain as well. So this one tends to look worse than it is, at least in my opinion, because we got square roots on both sides. Thank goodness nothing else is there, because that can complicate things. But I'm just going to square both sides. Okay, and again, that's just to get rid of the square roots. Square root to the power of 2, boom, gets rid of each other. So now my new equation is just 2x plus 6 equals 3x plus 3. And easy enough equation to solve here, because I can get, well, I'm going to put my x's on the right and then the numbers on the left. You don't have to, but you should get the same answer either way. The reason that is because I don't want the 2x's there, so I'd have to subtract 2x's, but this is going to give me a positive coefficient of x. So that zeroes that out, but 3x's minus 2x's is 1x, which is actually what we're trying to get out of this. But then I got the plus 3 in red on the wrong side. It's on the x side of things, so I got to zero that out by subtracting 3 from both sides. So 6 minus 3 is 3. So I get this one solution, but it doesn't work. So let's write these equations. Oh yeah, so that's true. When we replace the x's here with 3, we end up with the square root of 12 equals the square root of 12. Now, some students are like, well, I'm going to put this into a calculator, right? No, I don't really need to see the decimal. I know that the square root of 12 it just matches each other at least. So we know we found the solution. That's good enough. Well, this one's very different. You can square both sides right now. Let me show you what happens sometimes. It's not so common, just because all of this is kind of weird. But some students are like, hey, I'm going to square both sides right here. Watch this. I get 4x minus 3 minus 3x minus 5 equals 1, and then they solve that.
Something tells me that's not right.
That's not right. That is absolutely...
It'd be too easy.
Math people, right, it's too easy. It's a great way to put it.
We need to be more miserable.
We've got to, well, it's mental abuse to humans, so we should expect a little bit at least. So here's what we got to do, all right, is you can do that. It makes things super complicated, which I don't mind because I'm a math guy. But we're trying to make it as least complicated for class as we can. So what I'm going to do actually is I'm going to get rid of this square root of 3x minus 5. I'm going to put them on separate sides, because if I keep them on the same side, it's going to overcomplicate things, which I don't really want to go through. It can be done. It just sucks.
So we're just going to add a square root of 3x minus 5?
That's it. Add square root of 3x minus 5. Add the square root of 3x minus 5 on both sides, right? And that's a principle of equality, so it's okay to do that. And again, the reason I'm doing this is to get square roots on opposite sides of the equal sign, okay? So what does that do? It zeroed out that part, which is what we wanted. Now I can drop my square root of 4x minus 3 on the left. And then on the right, I've got 1 plus the square root of 3x minus 5. All right. Now, you may not believe that made things easier for us by the time I finish. you don't have to believe it, but it should. Okay, so now what I'm going to do is I'm going to take both sides and square them. Okay, now on the left, it does get rid of that square root, right? Because I've got the square root of something to the power of 2. Oh yeah, no, it is pretty ugly. So we gotta work with that sucker right there. Now I'm gonna do the work on this, I hope. So I'm gonna rewrite this. So I got 1 plus the square root of 3x minus 5. Let's make that a little bigger. But I'm multiplying it by itself. Okay. Now again, a common mistake here is where students are like, oh, 1 squared plus this, 1 plus this, and then it's done. No, it's a binomial now. So you got two terms, you have to show it as two binomials that are being multiplied by each other. And that's what makes it so fun. So now I'm gonna use some distribution, or some people like to call FOIL. So 1 times 1 there, and then 1 times the square root, positive square root of 3x minus 5, so plus, I'll just make it the square root of 3x minus 5. And then this one as well is square root of 3x minus 5 times 1, which is another square root of 3x minus 5. And then finally, I've got the square root of 3x minus 5 times the square root of 3x minus 5, which is, yeah, it's just 3x minus 5. Now, to clarify that that's where that came from, I will put that in parentheses. But I'm not going to below, okay? Now that I have that, I can start combining some like terms, right? So I've got my constant 1, and then way over here I got this negative 5. 1 minus 5 there would be 4. Yeah, negative 4, thank you. And then I've got, I'll do these square roots next. So I've got the square root of 3x minus 5, but I got 2 of them, right? Because I got 2 of those, so that I'd have positive 2 of those. And then also we've got this 3x that just drops, positive 3x. Wow, that's great. We're almost there.
Where did you get the negative 4?
All right, now we have another square root in an equation. So I'm gonna have to isolate that sucker. So let's do that. Let's start by, well, using a principle of equality, right? So anything added or subtracted, I'm going to zero out. So the minus 4, the negative 4 right there, I'm going to add 4 to both sides to zero that out. And it will. But negative 3 plus 4 is, well, positive 1. But also the 3x on the right there in orange, I can zero that out as well. So minus 3x's from both sides. I'm just going to show that as x. 4x's minus 3x is just x. You could put 1x if you want. But this now equals the square root part of that, which is not just the square root, but it's 2 times the square root of 3x minus 5. All right. As much in my heart as I want to get rid of that 2, I'm not going to. I'm not going to. Because, and specifically because I don't want to deal with fractions, right? Because if you divide by 2 right here and here, then you get a 1/2 x and then 1/2. And we're going to deal with a binomial that we've got to square. So I don't want to do that garbage. But what I would like to do is just square both sides at this point. We can do that, absolutely. It's a principle of equality. It's just, so let's focus first on the left side, and then we'll get to the right side, which is full of excitement. But now I got x plus 1 times x plus 1, which would be, I'd have x squared there, and then positive 1x, then another positive 1x, and a positive 1 right there. It's all multiplication, that's what distribution is. Then I can combine my x's to get 2 x's. Now I got x squared plus 2x plus 1. So that simplifies the left side completely. And this would equal the right side squared as well. Now, you're squaring both parts, right? So it's really just 2 squared, which would be 4. Now you got a square root, multiply, let me rephrase that. You're going to square the square root of 3x minus 5, which would have just been 3x minus 5. Now, at this point, I'm going to distribute the 4, because that seems like it'd be fun. And 4 times 3x's would be 12x's, and 4 times negative 5 would be negative 20. Now we've finally gotten rid of all of the square roots. As fun as it was, I still have an equation to solve though. So let's get rid of, again, I've got a trinomial on the left, which means I would like it to equal 0 and see if we can factor some stuff out. So let's minus 12x's first from both sides. So 2x's minus 12x's would be negative 10x's. And then we'll add 20 to both sides to zero out the negative 20 as well. So plus 21. And again, that zeroes everything else out on the right side, but I've got to drop my x squared as well. Well, hey, I've got a trinomial that equals 0. Can it be factored? Well, if we should expect these to be factored pretty nicely.
7 and 3.
Yeah, it's, well, not just 7 and 3, it's negative 7 and negative 3. Oh, you've gone beyond, yes. I apologize. Yes, so now I've got x's, right? And then I've got a negative 7 and then a negative 3, which is going to equal 0. And as much as you don't want to see this work, here it is. So if I can get x minus 7 to equal 0, that'd be good. Solving this, I would add 7 to both sides. And I get x equals 7. But also, if I could get x minus 3 to equal 0, that'd be good too. Just add 3 to both sides. And yeah, this work, not every student needs to show that work. But if you want to, that's fine. It's just not required, because if you understand that, that's fine. Besides, there's plenty of work here to look at. And if you got colored pencils like I do, it's pretty. But I've got two answers to check now, right? So I gotta let's go back and then get this entered into the original equation twice. All right, so I'll try 7 first in this first one. Okay, so let's replace that both x's. That's 7 there.
Oh, they are. They both are.
It's gonna work, huh?
Yep.
All right. Yeah, right here you get 1 equals 1, and that was a question mark. Now that's true. So we know 7 works. And the other one we had was x equals 3, so replace x with 3. Again, all this stuff I'm highly recommending you just put in the calculator. If you do it by hand, you know, like right here, 4 times 3 is 12, minus 3 is 9, square root of 9 is 3. Right here you got 9 minus 5, which is 4. Square root of 4 is 2. 3 minus 2 is 1. 1 equals 1. That's true. Got my question mark there. But again, that just confirms that we did in fact find the solution. This one is different because they got a cube root now, and well, we want to isolate it just like we would a square root, right? So I want to be able to take that cube root of t plus 4 and just make it by itself. So I got to get rid of that plus 4, so minus 4 from both sides. That's going to equal a negative 8. And where if this was a square root, then it would be no solutions. But because it's a cube root, we can continue. So I'm going to take both sides and cube both sides. Okay, because we got the cube root there. And cube will undo that. So now I have t plus 4 equals, so I got negative 8 to the power of 3. Make sure in the calculator you put parentheses around that. Well, I guess it won't matter because it's the same answer, but negative 512. This isn't too bad of an equation to solve, because now all I got to do is get rid of that plus 4, so minus 4 from both sides. And then it says t equals negative 516. Now that should be my solution, but I can check, right? So I can go back to the original cube root of t plus 4 plus 4, and this should equal negative 4. Let's find out. So the t I'm going to replace with negative 516. I got a question mark over my equal sign, so I'm going to put this in the calculator. The cube root on this one, to put it into the calculator, you type a 3.
Actually, it is 4.
Oh, good.
Or 8.
Yeah.
Can
So-
you show the calculator steps?
Yeah, so you type 3. This is telling the calculator that you want the cube root, and then you push second, and then it's that exponent button. So that's 1 button to the left of 7, and then 1 button up.
It is 2.
And then, of course, you type in your stuff. There's negative 516 plus 4. Then you got to push the right cursor to get out of that, and then push plus 4, and then enter. Boom. It's negative 4. So this shows that negative 4 does equal negative 4. That's true. So we did, in fact, find the solution there.